This is my first fear response, number 3, and here's part A. So basically, you have a 12-gram sample of a non-electrolyte, so it does not dissolve, and well, it does dissolve, but it doesn't separate, and it's dissolved in 80 grams of water, and it freezes at negative 1.94 Celsius. So that's a temperature difference. Usually, water would freeze at 0 degrees Celsius. So it says calculate the molar mass of the substance. So we'll use the equation that we know first, where we have the temperature change. We have the Van Hoff factor, because it doesn't dissolve. Well, it does dissolve, but it doesn't separate into particles, so it's only one particle. Here is the freezing constant, and here's the molality. So we're solving for molality, which is 1.04, and molality is moles of the solute over the kilograms of the solution, which is, the solvent, which is water. So we have 0.08 kilograms of water, so we solve for moles, and we get 0.083 moles of solute. They give us that we dissolved 12 grams of the sample, so if you take the 12 grams divided by the number of moles, we have 143.8 grams is the molar mass of the substance. So we're going to move on to B, part 1. So in this one, you have a sample of mercury chloride, and it weighs 9.41 grams dissolved in 32.75 grams of ethanol, and you have the boiling constant. So I guess we would assume that it would dissolve into 3 different particles. So we have the Van Hoff factor being 3. We have the boiling constant, which they gave us, and then we calculated the number of moles of mercury chloride by dividing the grams that we dissolved by the molar mass. And we get 0.0346 moles, and we already have the amount of ethanol we have. So we get the molality by dividing these, and we get 3.81 Celsius, which is the temperature change. On the second part, in the second part, they're telling us that the actual boiling point elevation is 1.27 Celsius. So if you divide the original by the number they give us, we get 3. So this shows that it's 3 times less, meaning the Van Hoff factor is actually 1. This means that the sample of mercury chloride does not separate into 3 different particles, so it's not soluble in ethanol. It does dissolve, but it's not soluble, which is why it's not an electrolyte, because electrolytes would separate into different particles. So moving on to letter C. We have equal amounts of helium and argon, and they're placed in a porous container. So we can assume that it's just 1 mole of each, because it's equal amounts. And this is the formula for rates of diffusion, which is 1 over the square root of the mass. So the molar mass of helium is 4 grams, molar mass of argon is 40 grams. So if you simply just plug it in the formula, you get 0.5 for helium and 0.158 for argon. And obviously 0.5 is greater than 0.158, so helium has a higher rate of diffusion, so it escapes faster.